Hello viewers, my name is Faiz Basurkar and in this video today I'll be talking about how to estimate the polar form of complex number, especially when the complex number is present in numerator as well as denominator. So let's say if we have been given that we have to express 1 plus 2i over 1 minus 3i in a polar form, which is r inside a bracket cos of theta plus I sin theta. We know that r in the polar form is the resultant of x and y, and theta is the angle made by this resultant with respect to the horizontal axis. I have also uploaded a similar video in which I have shown how to estimate the polar form of complex number, but the difference is that in this video we have the complex number in the numerator as well as denominator, and in the previous video the complex number was only in the numerator. Now let us try to solve this and get the polar form of this particular expression. So we will write down this as it is 1 plus 2i upon 1 minus 3i. So we have been given this expression 1 plus 2i over 1 minus 3i. So immediately what I will do is I will multiply this original expression with 1 plus 3i in the numerator and 1 plus 3i in the denominator. So whenever we have this kind of expression, so we have to always consider the opposite sign which is present in the denominator, and the coefficients has to be same but the sign has to be different. So if it is plus, we have to take as minus. If it is minus, as in this example, it should be plus. Now what we will do is we will factorize this. So numerator will be multiplied with the numerator and denominator will be multiplied with the denominator. So that will give me 1 plus 5i minus 6 divided by 1 plus 0 plus 9. So that will give me minus 5 plus 5i over 10. That will further give me minus 1 by 2 plus 1 by 2 of I. And this is nothing but x plus I into y. So this will give me the coefficient x as 1 by 2 and y as x as minus 1 by 2 and y as plus 1 by 2. So if I have x and y, I can write immediately what is r. So r is always under root of x square plus y square. So that will give me under root of 1 by 2 the whole square plus 1 by 2 the whole square. So this is nothing but under root of 1 by 2. Now we have been able to obtain what is the value of r. Now we need what is theta. So theta is tan of theta is always equal to y over x. I have also explained this in my previous video, and I will also try to explain this again in this video as well. So let me quickly draw this figure. So what I've done here is I have drawn the x-axis and the y-axis, and this is, let's say, the point z, and this is the angle theta. So tan of theta will be always equal to the opposite. So let me use some different color. So this opposite always is always y, and this adjacent is x. So tan of theta, as we know, is always the opposite upon the adjacent. So that's why we have written tan of theta is y upon x. Now what we will do is we will substitute the values of y and x in this equation. So that will give me y is 1 by 2 over x is minus 1 by 2. So that will give me tan of theta as minus 1. Now I need to find out the value of theta for which tan of theta shall be equal to minus 1. And for this purpose, I will be using the identity for tan. So that identity says tan of alpha minus of beta is equal to tan of alpha minus tan of beta upon 1 plus tan of alpha tan of beta. So this identity I have also shown in this particular slide over here. So I will take you back again over here in this. So how I can write this is tan of pi minus pi by 4 is equal to minus 1. So tan of pi, tan into bracket pi minus pi by 4 is minus 1. So how I can write this based on this identity that I have written here. So if I substitute alpha as pi and beta as pi by 4, then what I will get is this will become as minus 1. This is based on the values that I'm showing in this particular table over here. So as you can see, tan of pi will be 0 as highlighted over here by a circle, and tan of, let's say, pi by 4, that will be 1. So if we substitute all these values, then what we'll end up with is, so we will end up with this one, which is tan of pi minus pi by 4 will be equal to minus 1. So based on the tan identity, we write this pi minus pi by 4. Now this can be further simplified as tan of 3 pi upon 4 will be equal to minus 1. So which means that the theta over here is 3 pi by 4. Now we can write the polar form. So we know that the polar form can be written as z is equal to r into cos of theta plus I into sine of theta. So we know the value of r. We have already estimated the value of r. So that will be under root of 1 by 2 into the bracket cos of theta is 3 pi over 4 plus I into sine of 3 pi over 4. So this is the final answer. So let's say if we have been given the original form as 1 plus 2i over 1 minus 3i, then that's how we can write the polar form of this particular complex number, which is present in numerator as well as denominator. So I hope that you like the today's video, and thank you very much for watching. And if you like my video, please do press the like button. Please do comment if you have any questions. I'll try my best to respond, and share and subscribe and do support my channel. Thank you very much.